Alright, let's write an equation for a rational function whose graph has all of the indicated features, a horizontal asymptote with an equation of y is equal to 5, a vertical asymptote with an equation of x is equal to 4, and a hole at x is equal to 1. Okay, so we know that a rational function, let's say r of x is a rational function, it's going to have a function on the numerator f of x and a function on the denominator g of x. Now a hole will occur when the rational function is equal to 0 over 0, and that's going to occur when you have the same factor. So we know that the hole occurs at x is equal to 1, so your rational function should have x minus 1 on your numerator and x minus 1 on your denominator. Okay, so that way if you do plug in 1 here, you get 0 over 0, and this indicates, and this creates an indeterminate state, and this is one of the hallmark features of a hole, right? Now the other point that we need to do here is there is a vertical asymptote of x equal to 4. So I'm going to write down x minus 4 on the denominator, and now if you plug in 4 here, you're going to get some kind of constant over 0, and this is the hallmark feature of a vertical asymptote. Right, and the vertical asymptote VA occurs when x is equal to 4. Okay, so we have an x minus 4 on the denominator, and for the last step, we have a horizontal asymptote with an equation of y is equal to 5. Well, we know that these two are going to cancel out, so we need to put some kind of factor here that will create a horizontal asymptote of y is equal to 5. We understand that if you have a function that looks like axn plus c over bxn plus d, where the factor or the expression on the numerator and the expression on the denominator have the same degree, then the horizontal asymptote occurs where you have the coefficients a divided by b, right? So in this sense, I'm going to put down any kind of coefficient on any kind of expression with a power of 1, so a linear expression, 5x, with a coefficient of 5, because 5 divided by 1 will give us the horizontal asymptote, and I'm just going to put any number, right? So collectively, the function r of x is equal to x minus 1 times 5x minus 3 over x minus 1 times x minus 4 will basically meet all of these criteria. And you can obviously have different solutions to this, right? This isn't just the only answer. Your answers can vary, but for the most part, this is just a really quick way of meeting all of these criteria.